Let's talk about growing hope. The climate crisis is enormous, it's complicated, it's expensive. When I think about problems like that, my reaction is to take action. So come with me to a native forest and I'll show you what that looks like. The challenge I want to act on is this. Can a group of environmental science students plant enough trees to offset the carbon footprint of their annual field semester in the Hawaiian Islands? Here's the scale of the problem. After eliminating all the emissions we can, our carbon footprint is 70 tons of CO2 equivalent per year. So how many trees is that? We can figure that out, but first, anytime you plant any tree, you've got to make sure that you plant it right and that you plant it in the right place. Otherwise, the project won't be successful and may even cause more harm than good. For example, we don't want to cover the landscape with rows of identical non-native trees, like here in this eucalyptus plantation. We want to help restore the native forest. When you first arrive in Hawaii, almost nothing that you see will be a native ecosystem, and you actually have to work pretty hard to find forest species that arrived before humans did. The Hawaiian landscape has been extensively altered by human activity, especially by deforestation and non-native species introduction. Countless species are already extinct, and an enormous fraction of the remaining native plants and animals are threatened and endangered. The nearshore marine environment is at risk. Fire-tolerant invasive grasses are everywhere. Water resources and water quality are a big concern for island communities. Reforestation with native species has the potential to provide a variety of benefits. And when we reached out to local groups and got connected to the community, everything changed. I felt like Alice in Wonderland. We stepped through a doorway and entered a space that none of us had been and none of us had expected. The doorway to a place that's as fragile as it is beautiful. And as we work to restore a diverse ecosystem and the ecosystem services provided by an intact and healthy forest, we also met some of the most inspiring colleagues and mentors whose knowledge runs generations deep. What we're going to do is offer our energy and many pairs of hands to local conservation teams who already know how to restore native forests. And because the native species are unique, in fact, many of them are endemic, they live nowhere else on Earth, the project needs a lot of planning and a lot of infrastructure before we even begin. We need to know what kind of species used to live here and then gather seeds from remnant populations. We need to propagate the seeds, remove invasive species of both plants and animals, and cut a fire break all around the restoration sites. Then install so many miles of fence to keep the invasives out. In dryland sites, we need to bring in water and lay irrigation lines for the seedlings. Only then can we outplant. Of course, planting isn't the final step. Each year we come back and each new class of students monitors the previous outplants. What's the mortality fraction? What's the growth rate? And some of the plants that we work with are incredibly rare. Alpaca, this beautiful member of the violet family, was actually believed to be extinct. And when a tiny population of plants was discovered next to a new housing development, we helped our partners put little mesh baggies over every flower so that not a single seed would be lost. And when you're living on an island with the ocean almost always in view, it's absolutely evident that the land and the sea are connected. A degraded environment on the mountain is going to increase erosion and runoff and degrade the nearshore marine environment as well. The forest holds soil in place and actually increases water retention in the landscape. A Hawaiian saying describes it perfectly, "Hahai no ka'ua I ka ulula'au." The rain follows the forest. And even while our plants were still small, the change in the landscape was visible. There are more native species and fewer invasives. And we weren't the only folks helping with reforestation. A lot of local schools were taking field trips to the forest too. And the teachers, the students, the parents that we met were all interested in how much carbon a tree could sequester. So it was easy to take the technical literature that I'd been using with university students and turn it into something much more user-friendly that anyone, even kids, could use. The equations become graphs that map the diameter of trees onto the kilograms of CO2 that they've removed from the air. And since different tree species have different characteristics, we can make species-specific curves for different groups of native trees. Now the teachable moments and the co-benefits are multiplying all over the place. Kids are planting trees, and like us, they're monitoring and measuring their growth. So this is a great way to motivate math and science skills. And the trees are growing. We've been remeasuring the same cohort of trees for nearly a decade, and they're doing really well. In fact, some of the oldest trees have now sequestered a metric ton of carbon dioxide. And there's one more piece of this that's also really important. Kids in Hawaii are learning that the landscape they live in is an important part of Hawaiian culture. Traditionally, everything in the forest was put to use, and school curricula across the islands now include teaching Hawaiian language and cultural practice and traditional ecological knowledge. There's a clear synergy between the Hawaiian forest and Hawaiian culture. They each sustain the other. That's easy to see, for example, when thinking about what you would need to build a traditional voyaging canoe. Each part of the canoe requires different materials with different characteristics, all of which are found in a healthy native forest. Children who go to school in Waimea on Kohala Mountain have all been up to the forest where they've planted trees and helped to maintain and nurture that ecosystem. And many of them have learned to describe the different parts of that system with technical language and technical tools. They also learned to describe the ecosystems on the mountain in the traditional language of Hawaiian chant and dance. I'll show you what that looks like by inviting you, just for a minute, to an 8th grade graduation ceremony. You'll see one verse of a hula that describes the plants that grow in each ecosystem on the mountain and how the plants are used in traditional communities. This verse describes the coast, so listen for the chanter to call out to the sea, kahakai, and to the coconut, niu. And since this is a hula, above all, watch the dancer's hands as she describes the sea and the coconut tree. For me, and I think for these students too, being able to learn about ecosystems in different but complementary ways with different languages and completely different epistemologies, technical, verbal, kinetic, it deepens our understanding, encourages connection, and brings so much more power and actually beauty to our learning. And while we're waiting for our plants to sequester CO2, the co-benefits begin to accrue right now. Planting a tree is much more impactful and so much more hopeful than just sequestering carbon. And those who've done it will tell you so. Putting energy into the earth instead of taking from it is very satisfying. You see why you know things and how to use your knowledge. It's the tool and the permission and the inspiration to accomplish great things. And if you're wondering whether we accomplished our original goal, did we actually offset our carbon footprint? Here's the 5-year footprint I showed you, and here's what it looks like to scale with the CO2 that we expect our outplants to sequester. We added thousands of plants to the landscape, 70 different species, including 15 endangered species. And if we return to that hillside where we began over a decade ago, this is what it looks like now. When you take action, who knows? You too might be inspired to accomplish great things. And you know something? All great things start out very small.